Okay, the rider's on the Hurlo-matic, which, by the way, is not a ride at Oaks Park. It's a fictional ride. It's 2.780 G's at the bottom of the ride, right? So 1 G plus the ride is equal to 2.78 G's, right? So therefore, the ride is pulling 1.78 G's, right? Because 1 G plus 1.78 would give you 2.78, right? And then at the top, we're going to feel 1 G minus the ride. So that's going to be 1 G minus 1.78, which is going to be negative 0.78 G's, right? Or 0.78 G's inverted. Okay, what that means is that you could, at the top there, you could stand here. If the ride were big enough or you were small enough, you could stand here and you would be about 78% as heavy as you normally are, only you'd think down was that way. That'd be cool. That'd be a trip. That'd be like Cirque du Soleil or something like that, right? Okay, so this is at the top. I'm pretty sure that's one of the questions it's asking. So what do they feel at the top? What's it pulling? 1.78 G's. At the top, that is. And what's the acceleration of the ride in meters per second squared? Well, just take the ride. Don't take the top, don't take the bottom. Take the ride and multiply by 9.8. So 1.78 is the ride times 9.8 is equal to times 9.8. 17.44. 444 meters per second squared. Okay, so if they ask you for the period or the velocity or something like that, right, you're going to use this to find it, right? Don't use G's, use the meters per second squared.